Hey everyone, and welcome. So today we're going to dive into what is really the bedrock of any powerful AI system, data governance. Now, I know it might not sound like the most glamorous topic, but trust me on this one. Getting this right is the difference between building a total rocket ship and, well, a ticking time bomb. So let's just get right to it. I want to ask you this directly. Your AI is incredible. It's powerful. But what about the data that's fueling it? Is it a well-managed asset that's making you stronger? Or is it a complete disaster just waiting to happen? The stakes here are incredibly high, and today we're going to figure out exactly how to defuse that bomb.
You know, the key to getting control over anything is understanding its journey. And for data, that journey is the AI data governance lifecycle. Think of this as our roadmap for today's explainer. It's a complete circle, right from the moment that data is born to the moment it's securely laid to rest.
Okay, so every single piece of data starts its life right here. First up, we've got collection. That's where we're gathering all the raw information from all sorts of different sources. Then comes processing, and that's all about cleaning it up, transforming it, and basically getting it ready so our AI models can actually understand it and do something useful with it.
All right, now we get to the real heart of the matter, storage. This is where most of the complexity and, honestly, most of the risk is hiding. See, it's not enough to just dump the data somewhere. We have to follow a really strict set of rules to keep it safe, secure, and compliant. So, the very first rule of smart storage is you got to know what you're dealing with. And that's where data classification comes in. It's really just the process of organizing your data into different categories based on how sensitive it is. You can think of it like sorting your valuables into a regular safe, a high-security vault, or maybe even a maximum security bunker. So you might be asking, why does this matter so much? Well, because getting this wrong has huge real-world consequences. We're talking about devastating reputation damage if customer data gets out. We're talking serious security breaches. And of course, a massive financial hit from fines and just lost business. At the end of the day, it's pretty simple. You can't protect what you don't understand. Next up, we have to start thinking about geography. Seriously. Data residency is just what it sounds like. It's the physical place, the country, the city, where your data servers actually live. It's the where in the whole data governance puzzle. And this is exactly why that where is so important. Data sovereignty. This is the idea that your data is subject to the laws and regulations of the nation where it's being stored. It's basically the law of the land for your information, and it completely dictates who can access it and how it can be used. And what's so cool about this is you can see these concepts in action, right? On one side, you have a privacy-focused rule like the EU's GDPR. It's designed to protect the information of its citizens, no matter where in the world the company is. But then, on the other side, you've got a sovereignty-focused regulation, like in China, which says that data about its citizens has to be stored on servers physically inside the country. Two totally different ways of thinking about data. So if you only remember one thing about data storage, let it be this, right here. Know your data, that's classification, know its home, that's residency, and know the law of that home, and that's sovereignty. Okay, so how do we actually enforce all these rules on a technical level? Well, in big cloud platforms like Amazon Web Services, or AWS, one of the key tools is something called the worm model. It stands for write once, read many, and it's a really simple but incredibly powerful idea. Once data is written, it cannot be changed or deleted for a set period of time. It absolutely guarantees its integrity.
And a great example of this worm model in action is a feature in Amazon's storage service called S3 Object Lock. It gives you two main modes. First, there's compliance mode. This is the ultimate lockdown. For a set amount of time, nobody can change or delete the data, not even the most powerful root user. Then you have governance mode, which is a little more forgiving. It still protects the data, but it lets users with very specific, special permissions make changes if they absolutely have to.
And then there's this third, really special case, legal hold. This one has nothing to do with a time period. It's an indefinite lock you can place on data, usually when there's a legal investigation or a court case. It basically overrides every other setting and stops anyone from touching the data until that hold is officially lifted. So once our AI systems have actually used the data, which is what we call the consumption stage, its life cycle is still not over. We can't just leave it sitting there forever. We have to be smart about managing its retirement. The end of this data journey really has two final stages. First, data that we're not actively using anymore moves into an archive. And then finally, when the data is no longer needed for any reason at all, it enters the disposal phase, where it's securely and permanently deleted for good. Now, archiving is absolutely crucial for long-term data retention without completely breaking the bank. Services like S3 Glacier and Glacier Deep Archive give you extremely cheap storage for data you don't need to get to right away. And of course, things like AWS Backup are vital for disaster recovery, making sure you can get your data back if something ever goes wrong. So why even bother with disposal? Well, there are 3 huge reasons. First, it reduces your attack surface. I mean, data you don't have can't be stolen, right? Second, it frees up valuable and expensive storage resources. And third, a lot of compliance regulations actually require you to delete data you no longer have a legitimate business reason to keep. And that brings us to our final and maybe most critical point. You can't just set all these rules up and then walk away. Real, effective data governance is an ongoing process. It demands constant logging, constant monitoring, constant vigilance. So what exactly should we be watching? We need a complete picture. That means keeping an eye on the technical stuff, like how our models are performing and the overall health of our infrastructure, but also paying just as much attention to the security side, logging every potential threat, from failed logins to any kind of unusual data access. And being this vigilant helps us catch a whole bunch of malicious activity. We can spot things like prompt injection, where attackers try to hijack our AI with clever inputs, or even those big distributed denial of service attacks, which are just brute force attempts to overwhelm our systems and crash them. But here's the thing. Monitoring for hackers and system failures is absolutely essential. But for modern AI systems, it's really only solving half the problem. There's another, much deeper layer of responsibility we have to think about. And this is that other half, the responsibility checklist. We have to look beyond just the technical threats and constantly monitor for these deeper issues. Are our AI models showing unfair bias? Are they producing skewed results because of the data they were trained on? Are we accidentally violating copyright or misusing intellectual property? These are the tough questions at the very heart of building responsible AI. So, I'll leave you with this to think about. When you look at your own AI systems, is your data governance a well-structured safety net that actually protects you, your users, and your entire organization? Or is it just a tangled, confusing web that's waiting for someone to trip over? The answer to that question could very well define your future.